So let's go to cover the dot product. The dot product between two vectors. You have one vectors, you have the other vectors, A and B, and the dot product is a number. You have to understand that I give you two vectors, A and B. When you make the dot product A scalar B, what you are making is to give me a number. And this number represents something that we are going to study. So what is the definition of the dot product? The dot product of two vectors, A and B, is the magnitude of A by the magnitude of B by the cosine of the angles that they form. So if you have one vector A and one vector B, is the magnitude of A by the magnitude of B by the cosine of the angle that they have between them. So this is the definition of the dot product. It's clear that if A is perpendicular to B, what is A scalar B? What's the number? Well, will be magnitude of A by magnitude of B by the cosine of 90, because they are perpendicular. If A and B are perpendicular, A scalar B will be cosine of 90 is 0. So A scalar B will be 0. 0. If A is perpendicular to B, A scalar B is 0. So everything comes from the definition, from this definition. This is the definition that you have to understand what it means and what it's for and what the number means. If the number is 0, it means that A is perpendicular to B. So the facts is like this. A scalar B is a number, it's an scalar. What is I scalar I? So you have the vector I, one unitary vector in the x direction, and you have the vector j. What happens if you make I scalar I? Again, it comes from the definition, magnitude of I by magnitude of the second, b, I in this case, by the cosine of the angle that they form. In this case, the cosine is cosine of 0, so it will be 1 by cosine of 0, which is 1. So I scalar I is 1. You have to understand and remember this. And I scalar j is the same thing. The magnitude of the first by the magnitude of the second by the cosine of the angle that form I and j. The angle that they form A and j is 90 degrees p and p over 2. So I dot j is 1 by 1 by cosine of 90. Well, I said like this, if A is perpendicular to B, A scalar B is 0. So I is perpendicular to J. So that's why the dot product is 0. So think of something that I want you to see. What is I scalar I? Well, will be magnitude of I by the magnitude of A by the magnitude of I, which is 1, by the cosine of the angle. So will be the magnitude of A by cosine of alpha. By the magnitude of A by cosine of alpha is simple the component of x of A in the direction, so this is A, okay, this is I. So A scalar I is magnitude of A by cosine of alpha. But what is magnitude of A by cosine of alpha? Is this is magnitude of A cosine of alpha. Cosine of alpha, yes, I put alpha. So this is the angle alpha. So magnitude of A cosine of alpha is this distance, is the projection of A over the line I, over the direction of the line I. So this is AX, this is AX, this is AX. So A scalar I is, again, see the definition definition, A scalar I, in this case B is I, is magnitude of A by the magnitude of the second, that is I, is the magnitude is 1, by the cosine of alpha. But magnitude of I by cosine of alpha is AX. Why? Because cosine of alpha, you know that cosine of alpha is, look at this picture, look at here, look at C here, cosine of alpha is AX divided by A. AX divided by the magnitude of A. So AX is simple magnitude of A by cosine of alpha. So this is AX, the component of the vector in the X direction, in the Y, in the I direction. So I scalar A, the vector A scalar I, the vector A scalar I is simply the projection of the vector A onto the direction of I. Okay, of I. Of the line defined on the direction of the line defined by I. So again, I make the picture again. A scalar I is A cosine of alpha, and A cosine of alpha is this length. This length is A cosine of alpha, which is AX. So suppose that I can use it not only to find the projection of the vector into the line I can use it to find the projection of the vector A onto the line V of the vector B. This is the direction of the vector B, and this is a unitary vector in the direction of B. So what is A scalar u sub B? It's magnitude of A by the magnitude of u sub B. U sub B is a unitary vector on the direction of B, so the magnitude of B is 1. So it will be A by cosine of theta. Which theta? The angle that forms A with the direction of B. And what is magnitude of A by cosine of theta? Is the projection of A onto the direction of B. So A scalar u sub B is the projection of the vector A onto the direction of B, of the vector B. Okay. Let's go to do this, and we make a few problems of the using the dot product. Suppose that A is this vector AX, A is this vector AX in the I direction, and AY in the J direction. So this vector A is the vector AXI plus AYJ is the vector, AX, AY in the J direction. And suppose that you have B, and you want to find an expression, an explicit expression for A scalar B. This is the explicit expression. A is AX plus AYJ, while B is BXI plus BYJ. And this is the scalar product, a dot product. The dot product and the scalar product is the same thing. Dot product dot equal scalar product between vectors, okay? So if I make A scalar B or A dot B is the same thing, will be AX BX I scalar I plus AX BY I scalar J plus AY, VX, J scalar I plus AY distributive property AY, BY, J scalar J. Conclusion, A scalar B is equal to AX, BX is a number plus AY, BY. That's all. Why? Why is this the solution? Because I scalar I is 1, so I have this term AX by BX. But I scalar J is 0 because I and J are perpendicular. J scalar I is 0 because J and I are perpendicular. So, and J scalar J is 1. So this is the consequence of the explicit result for the dot product. So we have this, let me write a little bit. So what we have is A, to make a resume, A scalar B is magnitude of A by the magnitude of B by the cosine of the angle that form A by B. And this is also equals AX, VX plus AY, BY. And this is all that you have to know to make any kind of problems for the dot product. So I have selected some problems to practice. I will do one and you will do the others. Let me see. We can do these problems. So we have, I have select, let me see, vectors and vector additional. This one, 142. Find the scalar product of the two vectors, these two vectors, A and B, and this is A and this is B. Well, the scalar product will be AX by BX, 20, minus 14. So A scalar B will be 5 by 2 plus 7 for minus 2. This will be 20 minus 14. So A scalar B will be 20 minus 14 will be 6. So it's done. 141. 143. For the find it, you do it. For the vectors in figure 124. This is the figure 124, I suppose. Let me see. Yes, this is the figure 124. 143 say that for this make A scalar. You can do it again. You have to express what is B. B, for example, is 15 sine of 30, this quantity, or this quantity, if you want, in the I direction, plus 15 cosine of 30 in the J direction. This is B. Make the same thing with C and with D, and with A. A is very easy. A is 8 times J in the minus direction. This is the vector A. And the vector C, you'll do it, and the vector D, you'll do it, and you do the problem 143 and 145. Good luck. If you have any doubts, you let me know. Good luck.